Let the radius of this be A and let I be the current flowing through this. This is a long wire. There are 2 points are there which I'm interested. One point P1 inside, the other will be outside. So what is the field outside the solenoid? Outside the long wire, mu naught I by 2R where R greater than A. Straight away I'm going to conclude here 2 pi R where R greater than A. Will I agree? Field due to long wire outside the wire. What about, will there be any field inside S? If I go and check it now, there is also magnetic field inside. Okay, how to calculate that one? First, we'll define current density. J is equal to total current passing. This current I is flowing through the cross section of the wire. So how current density you define? Pi A square. Current flowing per unit area. This is what the current density will define it. So what is J here? Current density. Now take help of this one. So here what we should do, I am going to assume a amperes. This total radius is R, no? And let this be A. The total radius is what? We assumed it to be A. Let this be equal to small r. And this is the point P1. Where is that current I is flowing? At any one specific point at the axis? No, throughout that area of cross section. I'm writing current per unit area. Current flowing by area of cross section of the wire. Where current I is flowing everywhere here. The total current passing through that area is what? The I. So when you are assuming the, and what is this red color? This red color curve is what? The Amperian loop. Now I'm going to assume a loop like this. This is DL and B bar here will be directed in this way. What is the angle between B bar and DL? 0 degrees. Both are in, angle between them is 0 degrees. Then afterwards, how much of current enclosed in the Amperian loop? What is capital I? Current flowing through the cross section of wire. Current flowing through cross section of wire. What is I? Current enclosed by loop. So is it total current I flows through that loop? No, only a part of that one. How to calculate that one? I'll take help of current density idea. So therefore, what is I should be equal to J into pi R square. Similarly, what you studied in electrostatic gravitation, the same idea here, the current density. Current density is what? Current flowing through the cross section of the wire. Then how much of current enclosed by Amperian loop means current density into area of cross section of the Amperian loop. So we know value of J. This is I by pi A square pi R square. I R square by A square. This is the current enclosed. Now let's write the Amperian loop. B bar dot dl equal to mu naught I, not capital I. Everywhere B bar is constant, parallel to dl and constant. So integral of dl mu naught, this will be I R square by A square. 2 pi R mu naught I R square by A square. So how much B will be? One R will get cancelled. So mu naught I R by 2 pi A square. And this is strictly applicable for x less than or equal to A. We can justify our answer. On the surface, on the surface, how much it should be? According to this, put R equal to A. Come for this. Put R equal to A. mu naught I by 2 pi. Put R equal to A, mu naught I by 2 pi. Similar to in electrostatics, no, inside, on the surface, outside the charged sphere. Similarly, here also the Planck field. What about the direction? Concentric circles. Inside the wire and outside the wire, it will be again a concentric circles. This also you are supposed to remember. So the lines of force will be, what should happen to the lines of force? The spacing between them should decrease, no? They may test you with, okay, some rough diagram I'll give. Then outside what happened, the spacing between them should keep on increase because the B bar will decrease, no? And this is what that radius A. And the current I is flowing everywhere. And this is the direction of lines of force. There's a surface of conductor. Surface of why it's not a sphere. I'm showing only cross-sectional view. B bar, this is inside, this is outside. So now what is the Planck field inside the wire? Will be zero, non-zero. Will be non-zero. If a current I flows inside a wire, so how I'll make current to flow? By connecting it to a cell. And tell me what should happen to electric field inside the conductor? Must be non-zero, no? Oh. What should be the electric field inside the conductor? Should be non-zero. Then only current will flow. Okay, we are here, no? All of you, can you able to see the screen?
Yes, sir.
No. So there must be an electric field. Then only current I will flow, no? Tell me what will happen to the electric field inside and outside the wire. What about field here outside the point 2 and I'll take point 1. Now I want the electric field inside and outside the wire. Will it be zero or non-zero? Field at point 1 should be non-zero. Then only current I will flow. Otherwise not possible. So E1 is non-zero. What about T2? What about B1? B1 must be non-zero. What about T2? You draw Gaussian surface. What is the net charge enclosed by? Though the charges are moving, net charge enclosed will be 0. So field at 2 will be 0. What about field outside the wire? Must be non-zero. So they may test with questions of like this. Inside the wire, there's a iron wire. Then only current I will flow, no? So conductor. Now you should be very careful about all overall applications. They'll test with overall applications. The field strength at point 2 must be 0 because you draw Gaussian surface, net charge enclosed will be 0, no? How many positive ions are there? Those many free electrons will be there. So net charge should be 0. Okay, this is about due to long wire we have seen. If the current density inside that long wire, if it is variable,